Once again, an absolute pleasure to be back in the SUSE booth at Supercomputing here in Dallas. What I want to talk to you about is our common interest between Sylabs and SUSE about providing solutions for containerization that are suitable not only for the community here, but also, of course, for the enterprise. For 30 years, some of you may actually be 30-year veterans as I look around, I don't know. This show has been happening. And what has become, quite often the case is that what happens first, what gets proven in HPC at supercomputing percolates into the enterprise. And that's why, and that's in fact what we're seeing happening, is that there are a lot of customers who have compute-intensive requirements that, in the government and education space, we call them, HPC. And when you start taking that into the enterprise, we like to think of that as enterprise computing. So what I want to talk to you about today is making use of Singularity containers on SUSE Linux SUSE Linux Enterprise Server platforms, also known as SLES to its friends. Basically, you probably have some idea about containerization. The interesting thing about Singularity is it can be described in as few as 4 words. It's simple, fast, secure, and compatible. So simple. Basically, the entire container runtime gets encapsulated into a single file. So if you know something about how to work with files in the Linux operating environment, you've already got a bit of a step up in terms of your ability to understand and work with Singularity. Okay? So containers are used to package up an application often, and whatever that application needs. They're so much leaner than virtual machines because you tap into the host's kernel and the rest of the operating environment that's provided there. These containers are Singularity containers are also simple in as much as because they're running in user space, they make it a lot simpler to do things like access special purpose devices. And that's really where that 4th word, compatibility, comes into. So you don't have to do any heavy lifting to tap into GPUs if you're doing HPC or if you're doing deep learning. If you can basically run your prototype on even a laptop and start to figure out how to work with GPUs in that context, you're pretty much set for running that from within a container. It really doesn't change very much because of the way that we've implemented this. Fast. So the other thing that's very important is because the Singularity containers are designed, they basically came out of work that was done originally at Lawrence Berkeley. And people were coming to Gregory Kurtzer, who some of you may know is not only responsible for Singularity, but also for CentOS and Werewolf. They came to him with HPC requirements, which include things like, we care desperately about getting the best in terms of performance. So you will get a very small hit when you initially start up the container, when you instantiate the container, sort of 5 to 15 milliseconds, I think is what we tend to quote. But then after that, you're going to get near bare metal performance, even for NPI applications, very latency sensitive NPI applications. So that's another key thing. Security is another key part of what we're offering here. The containers are signed using a cryptographic key. And then when you actually use containers, you can do the correspondence check between what you expect in terms of the cryptographic key and what you're actually getting. So you can ensure that nothing happened to the container. The container wasn't tampered in transit, if you like. So that's really some of the unique advantages of Singularity. I'll say a little bit here. I'm not going to say a lot about GPUs right now because later on, through a use case example, I'll show you much more about GPUs. I'll also talk about how we're working towards standards compliance in terms of some very interesting and important projects. We'll hint at the fact that Singularity containers on SUSE Linux enterprise server platforms can make use of any one of a number of different workload managers. I'll show you an example later on that speaks to Slurm. We've said a little bit about some of these other points, and I think I'll just move on at this point. Now, if you have SLES platforms available to you and you want to start working with Singularity, it really couldn't be simpler. You can take advantage of the SUSE package hub, as you can see here. What you'll find in the Package Hub today is version 2.6 of Singularity, which is a good, solid release. Now, we've actually been working very hard. We've actually re-implemented the core of Singularity using Go, the Go programming language, that is Golang. And part of the reason we're doing that, as you'll see, is it really helps to get us to be, put us into good sort of stead, into a good place in terms of integrating with the rest of the container ecosystem, which is already taking advantage of Golang rather extensively. You will find the version 3.0 release, it just came out last month. You will find that version 3.0 release on SUSE Package Hub fairly soon. We're actually working with them to kind of tease out all of the kinds of things that enterprise customers would expect. So here's our latest marketing representative. You might recognize him. He's fairly well known in this community. NVIDIA's CEO, Jensen Huang. The NVIDIA has a cloud-based environment called the NVIDIA Cloud, NVIDIA GPU Cloud, NGC for short. And Jensen's known for giving terrific keynote presentations. And in his latest keynote presentation, he actually did this incredible visualization using ParaView, okay, where you could actually manipulate. If you were the scientist, in this case, of course, an astrophysicist, if you were, trying to understand a supernova situation, this was dwarf galaxy N22, I think, if I've got that correctly. I have a background in a different area of the physical sciences, so I'm not super deep on this stuff. But suffice it to say, they were manipulating a 7 terabyte data set, doing that visualization, basically real time. It was tapping into GPUs, and it was distributed using MPI as well. So a very impressive use case, and certainly the kind of thing now, because part of what all this is about, of course, is reusability. It's the kind of thing that anybody could do at this point. So I actually I tried to get the YouTube video that he was using, the YouTube capture of the keynote as large as I could, and I extracted some of the salient points. So one of the things that they're doing, they're using Singularity 2.6, which, as I mentioned, is available currently from the SUSE Package Hub. Good production release. They're using environment modules to bring into play the appropriate execution environment for the researcher that's doing their run. Huge fan of open source environment modules as well. They're using Slurm in this particular example to distribute the processing that's part of this visualization across multiple GPUs. So the GPUs do all the compute-intensive work, all the compute-intensive heavy lifting. MPI takes care of distributing the application across multiple GPUs in a actually, they didn't need a whole lot of GPUs. I don't think he was using very many because each individual GPU is so powerful. So anyway, this is the Slurm syntax, srun. There were all kinds of MPI-related settings that I won't, bring into play here. This is how you actually launch Singularity, and this says you want to run a container. And here's something else that's really interesting. In his example, and because so many of you have already invested heavily in building Docker images, and there are so many of them that are available on the Docker Hub, what he's also demonstrated for us is the interoperability between Singularity and Docker, which is a very advantageous thing. So we actually ran a Docker container using the Singularity command. He basically translated it on the fly into Singularity's container format, executed the whole application, and did this, just showed this unbelievably compelling visualization of a supernova, which I encourage you to have a look at in your, in your post SC18 state, whatever that might be. So we are seeing a lot of different examples. That's probably one of the finest examples that I've ever seen, in terms of demonstrating the capabilities of containerization with the rest of the Singularity community. The folks at Sylabs are working very hard to put a lot more in the way of examples out there. So currently you will find certainly some graph. Actually, we've got a peer review example that's in the works currently, so that should be forthcoming quite soon. But you'll find a number of examples of machine learning, even Internet of Things, all kinds of containers for different kinds of languages. If you like Jupyter Notebooks, for example, you can just go and grab a Singularity container that's got you all set up, and you can just get down to work. And you can see various other things, including graphics and databases. So this is actually an ongoing effort and accelerating rather rapidly. One of the places that these containers can end up is in the Sylabs Cloud. So very quickly, to just give you the right feel for it, it's kind of analogous to the Docker Hub, but we provide a number of unique capabilities there. So obviously there's a library for you to both store your containers, but also to use other containers that have been made publicly available. So that's a good thing. There's also a key signing and validation service. So I talked about that part of the importance of being able to ensure that the Singularity container you get is what you're expecting. Okay, so there's a key signing and validation service. So when you create a new container, you can sign it as well. And then when somebody uses it, they can do the validation piece using our new cloud capability. And then the third thing is we realize that sometimes mere mortal scientists and engineers, digital content creators, etc., who don't have root access might need to create containers. And in the process of building those containers, you might need to be root for some short period of time, for example, to install a piece of software in the container. So our remote builder service allows you to do precisely that. Okay? So, just kind of getting towards the close here, I just wanted to also share that we see not only great examples such as the example I provided from the NVIDIA keynote, but also very curious hybrid examples are starting to emerge. And so this is actually more of a design pattern or use case pattern than it is a specific use case example. We're seeing a lot of cases like this. So at the top, you've got this kind of somewhat traditional to HPC distributed processing to facilitate compute-intensive training, in this case in the context of a machine learning application, using in this example some combination of kubeflow and again Slurm, although again it could be Slurm or it could be Grid Engine or PBS or LSF, what have you, adaptive and so on, torque. In the middle, there's the Sylabs Cloud that I was describing you before. So it kind of becomes the way of, mediating between this traditional kind of HPC world at the top and much more of a services-oriented world at the bottom. So there we're seeing, in terms of people's use cases, the need for people to acquire data that is being streamed in real time. Maybe it's coming from a social networking service. So, all the attributes of big data that you need to be able to grapple with. And people are applying their machine learning models to that. And what we're seeing very commonly then is Kafka as the way of handling that data streaming requirement, along with technologies such as Kubernetes for orchestrating the workflows. And we've also got Nomad there for building more complex application workflows and so on. So these kinds of use cases are motivating us even more strongly towards some of the projects that I hinted at earlier. The need to work towards standards compliance. There's something called the Open Containers Initiative. And as you would probably expect, what's sort of first on the hit list is working towards standards around images for containers, as well as basically for how you work at the runtime level as well. So we're at the standards table, along with Docker and other players, working towards standards that are going to benefit all of the community, so that you have much more in the way of standards-based compliance and all the advantages and all the benefits that brings to the table. It's very interesting. I probably didn't say enough about this before. This thing here called SIF. This is the Singularity Image Format. It's also new to version 3.0 of Singularity, and it is what allows you to encapsulate the container runtime into a single file. So that's another new creation from us folks at Sylabs. We're also, as I said, integrating with Kubernetes. Basically, what we have in process now is we're building a gRPC server for Singularity, so that if you have a kubelet, which is basically a Kubernetes agent sitting on an arbitrary cloud instance or some kind of another node, maybe in your data center, you can actually interoperate with the with Singularity containers directly. We're doing some other things, such as natively supporting the Docker file syntax, and we're going to have a plugin released to help facilitate our integration with Nomad from HashiCorp as well. So I think I've probably gone a little bit longer than I perhaps should have, but we do have rewards, so please stay tuned. Thank you so much for stopping by the SUSE booth.
All right, let's give Ian a big hand for that.